Assalamualaikum, my name is Muhammad Amir Ashraf from Group F5. So today I'm going to show you the result for Lab PE2, which is simulation of three-phase bridge inverter with PWM control. So first, for the pulse generator, we must set the pulse width to 50% of the period for all the pulse generator. And the phase delay, we set it according to the table in the lab manual. And then for the stop time, we set it for 0.04 second and we run the simulation. After we run the simulation, we go back to the command window and type do's coding, which is simplot vphase, simplot vline, simplot vpol, and simplot iphase. So for vphase, vline, vpol, and iphase is term that I already named from each scope in the simulation. After we write the coding, it will display simulation data inspector, which it will display all the waveform from the scope, which is vphase, vline, vpol, and iphase. So this is waveform for vphase. So to read the voltage for V-phase, we just simply click the show data cursor and drag it to the peak of the waveform. As you can see, it is 66.7 volts for V-phase. And you can read it for the V-line, V-pole, and I-phase also. Thank you.
Hello and Assalamualaikum, my name is Daniel. I will be presenting on the setup of subsystem block in the carrier band PWM simulation. Firstly, for the function block to work properly, there is a variable VM and F which is needed to be declared in the callback section in the properties, where F is the modulating frequency set to 50 Hz and VM is the modulating amplitude varied from 1 to 100. Next, for the repeating sequence, this is the carrier signal. For the time values, it is set f times 50 because it is assumed the carrier frequency is 50 times higher than the modulating frequency.
Assalamualaikum, my name is Muhammad Irfan, and for this part we must run a simulation and find the result for carrier based PWM. For this part we are using the same circuit, but the difference is we add a subsystem which Daniel explains, and we delete the pulse generator and substitute the output from the PWM subsystem block. And after we set up the circuit, we can run the simulation, and using the same line of program we can find the result. So based on our findings, the waveform obtains are quite different from the reference textbook. The waveform is quite similar to 180 conduction method results. The setup was revised, but it was still unclear about the cause of this error. So that's it for me. Thank you.